Hello. So I'm going to talk about generator. Okay. And so the generator we have, it's going to be, so we're going to have the B field that's going this way. Okay, that's the B field. So I'm going to draw it in 3 different orientation. So sometimes the hoop is going this way. And sometimes the hoop is going this way. And the other time the hoop is going this way. Okay, so that's the axis of the hoop, of the wire loop. Okay, so this is 3 different time, right? So sometimes it's like that, and sometimes it's like that, and then sometimes it's like that. So this is rotating. So the way I'm drawing it, this is rotating with a constant omega right now. So angular velocity, right? Constant angular velocity. So when it's doing that, and this wire, so generator, the input is motion, right? So angular motion in this case, right? So it's angular motion here. And the output, right? The output is the electricity, right? So it's the current, right? So the current and the EMF, right? And also, you can say the output is the power, right? Okay. So then let's take a look, see how we do this. Okay. So let's say if I have my B field, I'm going to plot it a different way now, right? The constant B field, right? The constant and uniform B field, right? So the B field is, say, like that. Okay. And let's say if I have my area, right? So my area is like this right now. Okay. Right. So you would then have this one here is rotating like that, for example, omega, right? So of course I shouldn't be drawing like that. I should draw, let me changing color here. I should be drawing more like that, right? And there's nothing there, okay? So when I turn, you expect the current will come up, right? So right now, this is at the maximum. So this angle here, it's in this angle here, right? So this is at the T1 right now. So then when you turn your flux, right? So your flux is the flux is equal to B times A, right? And then so right now this cosine theta is cosine 0 degree, right? So that's equal to 1 right now. Okay. So as you turn this theta, it's going to be equal to not 0 but 1, 2 until 90, right? So it's going to be changing. So so this flux is changing, right? So we know if flux is changing with T, then that will give us a induced EMF, right? So this is induced EMF. Okay. So that's what we're doing right now, right? So we're turning with the omega, and then we hope to generate current. So you can see in this orientation right now, the flux is reducing, right? Flux is reducing. So it's reducing that I'm trying to increase it. So then I will then have, at this moment, I will have my induced current going this way, right? So it will be clockwise right now, right? So then this one here will be going out, right? Going out, that will be going in like that. So that's your current, induced current. Okay, so you can see if you get your right-hand rule, and then you'll see that the induced is trying to counter, right? Trying to let's see. So he's reducing. Sorry, he's reducing, right? So he's reducing. So I need to help him. Sorry. So this is wrong, right? So this is I'm not helping him right now. I'm actually hurting him. So I need to go the other way, then I'll be helping him, sorry. So this should be the other way around, okay? So let me go backward. Okay, there, right? So I need to help him, right? So how do I help him? I need to go coming out too, right? So need to go this way, okay? Sorry about that, right? So it's had to go that way. So I induce, had to be going that way, right? So that would be counterclockwise, right? Okay. So this will be going this way, and that will be going that way, and there's nothing there, okay? So then you would generate your current, and then you would then use that, right? So that's the purpose, is to generate the current, right? Okay, so let's just try the right-hand rule again. So on the right side of the edge, I put in my current going upward, and then as I do the right-hand rule, it will try to increase the B induced will be also going out of the page. So then it will be helping in everywhere you go. You see that? It'll be helping everywhere you go. Okay. So that's why I want to do it, because he's losing at this time. Okay. All right. So that's clear enough. Then let's continue. Okay. So let me erase a little bit of this guy's here because I need some area. So let me do that. Eraser. I'm going to erase that. Okay. So I need to do the delta phi, delta t, right? Okay. So, all right. So I think that's maybe good enough for now. Let's see. All right. So we're trying to derive the epsilon, right? So epsilon is equal to delta phi, delta t. I'm dropping that negative sign for now. Okay. We can add it on later. And that's equal to delta BA cosine theta, right? And then delta t, okay? So the A is constant, right? This A is constant, right? That's the A right there. A is constant. And B is constant. B is constant everywhere. So that BA can come out. So BA. And that will be delta cosine theta, like that. And delta t, okay? So we know theta, right? So theta, so we know omega is equal to delta theta delta t, right? So then delta theta, right? So here it's theta final minus theta initial, and then t final minus t initial. And if we make this one to be t initial and theta initial both 0, then this one can be rewritten as just theta and t, right? There's an f there, I'm just dropping them. So then theta is actually equal to omega t if the initial time and the initial angle is 0, right? So I can use that. So then I will have BA delta cosine omega t and then delta t, okay? So this here, I'm just going to assume that you have studied some of those calculus stuff. So then this will come out to be BA, and then omega will come out, okay? And then that will become sine omega t, okay? And then there will be a negative sign coming out too. So there will be a negative sign coming out like this, okay? But there was a negative sign right there. So there was a negative sign everywhere, right? So then that become positive, right? So now in the general case, you don't just have one loop, right? You have multiple loops. So I'm just changing color here. So you may have n loop, right? The n loop of this wire, okay? So then this one here would then become epsilon, would become omega. I'm gonna bring the omega here, and then n, right? N loop, and then BA, and then sine omega t, okay? So this is easy to remember because this is like a woman NBA, right? So woman National Basketball Association. So WNBA, right? And then sine omega t. So you can use that, all right? So I'm gonna clear that and just talk a little bit more about this equation. So epsilon, it's equal to omega NBA or WNBA, and then sine omega t. Okay, so if you want to make this one, right, make this one change, right? Let's say you want to make it larger, then one way to do it is to increase the angular velocity of the motion. Okay, that's one way. Another way to do it is increase the number of the loop, right? So increase that. Another way to do it is increase that B field, right? So increase this B field, and then, or you can increase the area of that wire that's inside the B field. Or you can see that, not all, but you can see this epsilon, this EMF, is changing with time, right? So if you plot it, you can see this is not a constant like a DC EMF, right? So sine omega t looks like this, right? So you go like that. That's the sine omega t shape. And this one here would be the omega in BA, right, for the maximum. And then that would change with time depending on your omega. So that's how, so it's called alternate, right? Alternate voltage, right? Okay, so this is called, it's called alternate, right? AC, right? Alternate current, or DC is direct current, right? So this is so-called the AC, 交流电, right? In Chinese, that's 交流电. So you're producing, alternate current right now, alternate current through this type of device. Okay, so that's all we have, and hopefully you're learning something. And